Okay, what's next? We have all of our hardware defined in the computer in a way where we can understand what it is and how to manipulate it. And this is going to be real apparent pretty quick here. Now we move on to the next layer of programming for this mini tank, this little robot. And as we move up in layers, we increase the intelligence of things as we go along. You know, these things now can handle themselves. You know, they can. You know, you send them the directive or a command or ask them something. You know, like in the case of Sonic, you ask them what the distance or whatever it is, and now they can handle themselves, and we don't have to worry about the details of how they do those things. It's like when you drive your car, you don't worry about the details of how the pistons fire. You drive your car, you go down the road, and you pay attention to traffic. You got more important things to worry about than how every piston is firing, how much fuel is going in the cylinder, and all this stuff, like every moment of the day. So that's sort of how you deal with this stuff, and that's how you increase your complexity without getting overwhelmed. So our next step, and I know I call it eyes, it's actually a sonic sensor, but it looks like a set of eyes. So I give it the name eyes because it's cute. So I'm going to call this next layer, I'm going to call this object a set of eyes, because that's what it is, eyes. And then of course this object is going to be the tracks, because I've identified the eyes and the tracks on the unit. So let's do that. Let's do the easy one. Let's do the tracks. So let's go ahead and close our angular stepper motor, because that's part of our eyes. Now if we bring up bidirectional stepper motor, or bidirectional motor, we now have this object and its blueprint that we can base off of to create a new higher level object called tracks. So I'm going to go right here, I'm going to do it the same way, class, and I'm going to say tank tracks, okay, because it's a mini tank, tank tracks sounds pretty cool. Oh, put it in the wrong place too, didn't I? Put it right here. And then I'm going to say tank tracks have a blueprint. They have a blueprint. And of course, the name of our file is going to be tank tracks. And by repeating all this and explaining, hey, what happened? That's because I was trying to chew gum and talk at the same time. By explaining all this and moving through this line by line, literally like this in the slow method, we're being repetitive here. I'm being repetitive here on purpose. So if somebody's trying to learn this stuff, through the repetitiveness, they start to pick up this, oh yeah, that kind of makes sense. Oh, it's a set pattern. Oh, it's a standardized method. Because what I'm doing is all standardized methods. It's all stuff that you can repeat over and over and over, no matter what you have, and build really complicated programs out of, and start out very simply like this with these same set patterns and same set ideals and same sets of ideas that get you there. And that's how I program. It's pretty cool. Okay, so I'm going to do this, and you can see that it's becoming repetitive, but now each time it gets a little more interesting, so we don't deal with all the details of every little tiny thing. As we go up to each layer, each rung of the pyramid there towards our goal, which is our mini tank, which is the whole device, we not only we use the lesser things to get us there now at this point. So of course we have a class called blueprint, and of course we have a private area, we have a public area, and of course here's where it gets interesting. Okay, let me go get the mini tank. Actually, let me go find it and just describe a couple things first. Okay, I have this mini tank. Okay, and that's what we've been programming the whole time. Of course, I showed it at the very beginning of this video series. And this is what we're going to program right now, these two tracks. Now, here's the cool thing about this little robot. Because you have two tracks, and it's not just four wheels, you've got some abilities. If both tracks are moving forward at the same time simultaneously, okay, if they're moving forward at the same time simultaneously, then we can call that forward, and that means both servo motor or both bidirectional motors are moving forward And we'll just say, move forward at maximum speed will be forward. And of course, if both motors are moving reverse simultaneously, we can call that reverse at maximum speed. And if this one's moving forward, if the right one's moving forward at maximum speed, and the left one is running at a reduced speed, then we're going to arc towards the one that's going slower. So that means we can arc left as we're going forward. Like if somebody takes a car wheel and steers it to the left, we can move forward and arc to the left. It would just slow down the left tracks. And if we slow down the right track, we'll arc to the right. And of course, if we're going backwards at full speed, and then we slow down the right track, we'll arc to the right going backwards. And if we slow down the left track, we'll arc to the left going backwards. So whatever track we slow down, we'll arc that direction. So that gives us, and then of course, since it's tank tracks and not four wheels, we can move this one forward at full speed and this one at reverse in full speed, and that'll actually make it rotate this way or rotate that way. So the way I see it, you've got forward, backwards, arc to the right, arc to the left, going forward, each one of those going forward, and then arc to the left and arc to the right going backwards. So that's forward is one motion. Reverse is another motion. Arc to the right, is another one. Arc to the left is another one. Arc to the right backwards is another one. Arc to the left. We got about 8 different motions. Rotate right, rotate left. These are all advanced abilities that we can give the mini tank and not worry about how to do them, because we have 2 bidirectional motors, and we can inherently build in to the tank tracks these abilities, and that's what we plan on doing. So we're going to make this thing smarter by teaching this thing how to perform those functions on a higher level, so that our mini tank, which would be the whole object, the final result, the robot mini tank itself, could say, hey, I want to arc to the right going forward, or I want to arc to the left going forward, or I want to run forward, or I want to run reverse, or I want to rotate around. So I can just simply do those things without having to worry about what is that left motor doing, what's its speed, and what's the details, and without any details, without having to dig down into the lower level hardware. I can just say, hey, tank tracks, you're an object, go do something, go forward, go right, go left, arc to the right. So we can give those higher level commands. We can also define them. So I think that's pretty cool, and that's how we're going to make this thing smart. That's how we're going to improve its intelligence. So the first thing we're going to do is we're going to make an enumerator, which is going to give us some, so we can define all that stuff. And we can say forward equals, let's say 1. We forgot the word stopped. Of course, we need to be able to stop. Equals 0. We always make stop 0. That's a good way to start out. Forward equals 1. Reverse. I'm just making this up as I go. Equals 2. It's making up the numbers as I go. We can give it any number we want. We're just going to use the names. Rotate left equals 3. It looks like we're going to need a little more space here. Make everything line up. Rotate right equals 4. And then arc left forward, and we could call that one 5. Arc right forward, and call that one 6. And then arc left reverse is going to be 7. And then arc right reverse, and we'll give that one 8. So that's about 8 different directions. Now we know all these are commands, basically. We can tell the tank tracks, hey, stop. We'll just call this stop. Now you can't use the word stop, I think, singly. It conflicts with some of the C++. A lot of people just use stop with 2 P's because of that. Stop, forward, reverse, rotate left, those are basically commands. So we can give it those commands so it'll know those commands. And of course, publicly we can say void, because we don't need any data back. We just want to do it. Set, what do we say? Set motion. There we go. And then of course int8t motion. And of course we need to include the Arduino library, but we can do one better, because we're going to be using our bidirectional motor, and our bidirectional motor actually includes the Arduino library itself. We can just include the bidirectional motor, and it'll also bring in the Arduino library so that it recognizes all this data types. So we can do that. And of course, what do we need privately? I don't think we need anything privately right now. All we really need to do, well, privately we need to have 2 bidirectional motors, of course, one for the left track and one for the right track. We don't need those public. We can make them public, but I don't see a reason to for this little mini tank. So we can say bidirectional motor. I want you to use the blueprint to make me a private member, m underscore left motor. And of course, I need a second one. Use the same blueprint to make me a right motor. And of course, we need to set the pins on this, because now here's the layer in which we set the pins, because these mini tank tracks are not generic to every device out there, or every kind of mini tank, or every kind of robot. We could make it generic, and we could request that upon the building of the blueprint. Like let's say mini tank, as it creates a blueprint, or the tracks from the blueprint, the next layer up, we could have it forward what pin numbers to ask for, what pin numbers to set. There's really no need to in this example. On this little robot here, because the mini tank tracks are basically specific to this robot, and as long as your header file and your CPP file for your object is specific to this project only, you can go ahead and start assigning numbers to your pins and all this stuff in that layer in that layer. So basically what I'm talking about here is, we've got speed and direction pin for each of these motors. Where do we set the value for that? Well, we haven't set the value of that in our bidirectional motor object code. We made whatever device is going to create one or use this, set it. And of course, we don't have to set it here either. We can say, hey, we still don't want to set it here, but we can make the mini tank set it when it creates a set of tracks. We can forward that information all the way down to here, but I don't think it's necessary, because this is proprietary to mini tank. In other words, the entire CPP file and header file is only ever going to be used in this one mini tank project. In this case, so if we were going to make tank tracks that were generic to a bunch of different kinds of robots or something, I would probably make it more generic and then make it ask for the pins that go to here. So there's some differences there. So how we do that in our blueprint, we still have to say blueprint, and then since we're not going to ask for any information, we're just going to leave it blank, but we still need to make it in our code space. And then assign, just like by the way kind of thing. So we go here, we go source, implement method, select everything and hit OK, and then we go here, we have our blueprint. And of course, we're not going to really do anything on startup except maybe, well, I can't think of anything on startup, but we do have a by the way. I want you to, we need to set the value of m underscore left motor to our 2 Arduino pins, okay? And then instead of just putting numbers in here, just 12 and 11 and 10 and 5, why don't we in the private area here, why don't we define that right here next to our motors. So we'll go here and I forget which is which. I had to figure this out the hard way. So let me, oh, here we go. The left direction pin is 12. And so we'll go back here and we'll say left motor direction pin equals 12. Left motor speed pin equals what was that? 3. Right motor direction pin equals 13. Right motor speed pin equals 11. Let me just verify that. 13 and 11. Yeah. Okay. Now we can come over here and assign that upon creation. The left motor is going to have the left motor, left motor direction pin, comma, left motor speed pin. Of course, we also need to set the right motor and the right motor direction pin, comma, right motor speed pin. And because it gets a little long, we can do this right here. And you take no inputs. By the way, I want you to set this, and I want you to set this. And of course, we're not going to do anything when we create this, or whenever it's created. Now, set motion. And our motions are going to be these preset motions, okay? So what I'm going to do is I'm going to copy this so that we have them over on that other screen temporarily. And we can say, instead of if it's stopped, set it to this. If it's forward, set it to this. If it's reverse, set it to that. Instead of doing that, we just use a switch statement. A switch statement basically lets you select between several things. So how a switch statement works, switch. And then, of course, a context within the switch statement. And of course, switch what? Between what? When the value is equal to, or when a value, check a value and determine its, and based on its value, we want to switch to this case, and then of course switch case statement. Case what? When it's stopped, perform this context. And of course, we have 8 of these, and of course, this one's going to be forward. There is something missing here. And when we're done with each of these contexts, so that we don't run into the next case, we say break. In other words, jump to the bottom as soon as you're done performing whatever's in here in these brackets. So let's go ahead and there, and we're not having to type it in 8 times. Forward, reverse, rotate left, rotate right, arc left forward, arc right forward, arc left reverse, missing one, and arc right reverse. Of course, what happens if we ask for a motion that this thing doesn't recognize? Well, we can do this default return. In other words, ignore anything else that's not one of these cases. There. Now we can get rid of this. And we can write code for each of these. When we're stopped, we want to say m_left motor dot set speed 0. And of course, we can say right motor set speed 0. Did I misspell right motor? Yes, I capitalized by accident. There we go. There we go. And of course, copy. And then we can do this. And then we can do this. And we can do this. And we can do this. Just to get us some code space in each one. Let's start out that way. There we go. Now for forward, we want to set the speed to a bidirectional maximum speed forward. Of course, we do that for both motors to go forward. And to set reverse, maximum speed reverse. Hey, dummy. And rotate left. The motor that has to do the odd action is always the direction it's going to go in. So rotate left would mean the left motor goes reverse and the right motor goes forward. And then rotate right, the left motor goes forward and the right motor goes reverse. And then arc left forward. Now here's where it gets a little interesting, because we're not really stopping one of the motors or reversing it. We're going to slow it down. So we need a value to slow it down by. And we can say at the top here, just an enumeration real quick, speed reduction. And then I know that by playing with this robot before, about reducing it by about 100 slows down the one track enough where it'll do an arc. And then of course arc left forward. So the direction you want it to go is the motor that has to slow down, minus speed reduction. And of course arc right forward is going to be, both of them go forward, but the one that slows down is the direction we want to go, so speed reduction. Of course it's going to have the same way. except we're going to be going reverse. So we're going to do this, and then of course we're still going reverse here. I'll post them in there. And then the left motor is the one, the arc left means the left motor has to have the speed reduction. And of course, arc right reverse, the right motor has to have the speed reduction. There we go. Simple as that. Now we've got some logic with a switch statement. Say, hey, whatever motion it is, if it's stop, do this. If it's forward, do this. Of course, if it's do this and then brake. If it's reverse, do this and brake. If it's rotate left, do this and brake. Brake means go to the bottom. And of course, we're not returning any data. So that's it. So now we have a set motion routine that will set a motion based on what motion we ask, and it will individually tell the tracks what to do without our intervention. Okay, there's one last detail or so. I had to change that. I was accidentally capitalized one of the letters. Fix that. And you know, we have a left motor and a right motor, and in our blueprint creation, we are assigning our left and right motor to the correct pins, but we also need to run the begin routine for our bidirectional motor. You know, our bidirectional motor has a begin routine here that will set those pin modes. So we need to actually perform that begin routine on each of those motors. So what we can do is we can on our next layer up, you know, on this layer here, we can make a begin routine here and have that begin routine run the begin routine for both of these motors, so that it covers both of those. And of course, it's like a pyramid. You know, you eventually will have a mini tank, and the mini tank will have a begin routine. The begin routine of the mini tank will run a begin routine for the eyes, which will run the, you know, and then the eyes will begin routine will include the begin routine for this and this. Yeah, the same thing. The mini tank will have a begin routine. It will run the begin routine for the tracks, and then the tracks begin routine will run the begin routine for each of our hardware objects. So that's how it'll flow, so that everything stays in sync. So we need to put a begin routine in here, which we didn't do. So, and then this begin routine obviously is simply going to we define it, is simply going to take our left and right motor and run their respective routines so they can initialize the pins on each of their motors. So that's how that's going to work. Sort of like a tree branching out and running all these routines to get everything done and coming back as it goes down through these layers. And this one's supposed to be the right motor. There we go, left and right. So there we go. So now we have the begin routine. I don't see anything else that we have to do here. We have a set of tracks. We can initialize the tracks, which will initialize the motors. And we can set a motion and what motion we want, and that motion is one of these commands. Sounds good to me. That's all the robot really needs, the mini tank robot really needs. We can add functionality to this later, possibly, you know, and have the tracks like where we could set the, you know, like, you know, maybe have a speed or have the tracks going forward, and then have maybe an imaginary steering wheel, you know, that'll make the thing steer whatever, you know, however far we want to turn the steering wheel left and right. So we could actually put a steering wheel in here and put some more functionality here, but we don't really need it for the mini tank, because we're just basically emulating this original program and its abilities, its functionality for now. in this tutorial so we don't get overcomplicated. But yeah, see, it opens up possibilities. The more you have, like, some objects that work in tandem, the more you can create new ways to interact with the world, or interact with your program can create new ways to increase its intelligence or its abilities with generalized commands, the more generalized operations, rather than having to detail and specifically down to the atom do things, which is pretty nice, the way I program things. So we're done with this. We're done with this layer. Now let's move to the eyes that use sound to look, I guess, sonic eyes. That'll be next.